All right, welcome everyone to another Silicon Labs product podcast. This is our second podcast where we're lucky enough to have Max Palumbo join us. We're going to follow our discussion on Bluetooth mesh, and Max, he's going to go into a little bit more details on the technical side of things and explain a few of the points he made on the prior podcast. So Max, thanks for joining us again.
Yeah, glad to be here.
So one of the things I was interested, I sent this to you as one of the reasons I wanted to talk with you, is now that you're working with Silicon Labs, the EFR32 family, you're designing them into your control systems that you're working on at Katera. What are some of the advantages that you've noticed with the devices beyond just our software controls? I'm talking more of the devices themselves. What are some of the benefits of the EFR32 architecture that you've found?
Yeah, as a product designer, there's a couple benefits that are really important to me. We touched a bit on the software and the feature support last time. In general, the architecture of the software SDK is a really powerful thing. So one of our biggest considerations as the wireless division of an IoT networking company, I guess, is security. And if anybody follows the tech news at all, they might have noticed in the last couple of years there's been a few Bluetooth-specific press releases, and it's something that makes us nervous as a product design company, because if we don't pick the right partner for our networking technology, we could be exposed to some of these security vulnerabilities that come up. Fortunately for us, none of the last, I'm going to say 3, maybe 4 security vulnerabilities to be announced as sort of general Bluetooth issues have impacted our products, because we chose to work with Silicon Labs. So a lot of that comes down to is that Silicon Labs is using Mbed TLS as their cryptography layer. That saved us from at least two of the last couple of bugs, and we've standardized internally that any embedded device, it must use a pre-approved cryptography library that's on our list of approved. So when we evaluate new vendors, that's one of the most important criteria. Is you might tick every other box in terms of power and price and package and software features, peripheral performance, but okay, what cryptography library are you using? What version of it are you using? That has been a deal breaker for several other vendors that we considered for some of these projects, is that they just weren't using security libraries that we trusted. That was one of the main benefits of picking Silicon Labs. It's not only about picking the right security layers, but it's also how they get integrated into the SDK. So a lot of the product level security features we're taking advantage of are things that were deployed by Silicon Labs. So they've been tested by multiple platforms and deployed relatively widely in the market. So things like the cryptography features in the bootloader for encrypting the firmware image that we download and signing the firmware image that we download with a public key that we use to verify the signature. Those are all baked into the SDK, built on top of the widely available open source cryptography library. Those are things that are really important for us. There's a lot of other more subtle things that we like about working with the Silicon Labs parts. Compared to some of the other competitors in the market, the chip itself is relatively easy to design with. So you don't need a lot of external components, and the parts that you do need are all relatively cheap, just resistors and capacitors. The package for the device is quite easy to work with, so it's just a standard 0.5 millimeter pitch QFN. We've actually done designs with that device on a 2-layer board. So it's one of those hidden costs that you can get hit with if you're looking at other devices like BGAs or LGA type packages. They might be physically smaller and the cost of the component might be cheaper, but then you have to look at the total system cost and say, okay, it's a 4-layer board instead of a 2-layer board, and I can't route out the internal signals even if it's a 4-layer board without doing microvias or VIN pads. So the cost that you save on the chip is eaten up by the cost of the PCB fabrication technology. Our decision-making criteria was to go with a cheaper PCB, a more expensive chip than, say, something else on the market that lets us build a cheaper PCB, that lets us inspect it for lower cost and assemble it for lower cost. And overall, even if it's 5 or 10 cents more for the chip, it ends up in the wash when you take into account the total cost to manufacture and test the system. So there's a lot of other features like that about Silicon Labs that have been really nice.
All right, great. I'm sure maybe we can have other conversations in the future about some of those other benefits. Moving on to another question that I've had and things that I've heard from other people is, how have you, Bluetooth Mesh currently is uses a flooding network style or architecture. I know you're working in the Bluetooth working group to establish a different solution, but how have you worked with the current flooding network style of Bluetooth Mesh?
Yeah, that's a really good question. It's true that Mesh 1.1 will introduce a routing feature. It's still under development within the working group, so if you're interested to learn more about that, you would have to join the Bluetooth SIG as an associate member in order to get access to the specification documents that are still in progress. But for the current deployment, it's not I guess you could call it a naive flooding network. It's a managed flooding network. So the network layer of Bluetooth Mesh right now, the way it works is that there's several layers of filters to decide what packets I should relay or not. The first layer of filter is to say, I just received an advertising packet. Is it for my network? So there's a network ID that gives you a hint as to how to decrypt it, and if I can decrypt it, okay, it's for my network. So I go to the next step. Is it in my network cache? So if this is something that I've seen within the last some number of packets, then I shouldn't send this again because this is a repetition. Does the packet have a relay flag in it? So is the TTL greater than 1? If it is, then I should decrement that value and resend the packet. So, and then again, the sort of last layer of filtering is this packet for me? So is the destination address something that I'm subscribed to? And if it is, then I probably don't need to relay it. I simply pass it up to the application layer. So it's a little bit more sophisticated than just I saw something, I should repeat something. So that's sort of a very high level look at how the network layer in Bluetooth Mesh works. The type of node that you are also makes a difference. So a typical end node has several feature bits about what functions it's able to perform. So those feature bits in no particular order would be friend capability, low power node capability, proxy capability, and relay capability. If the relay feature bit is set to, I'm probably going to get this wrong off the top of my head. If it's set to 2, it means it's not supported. If it's set to 0, I think it means it's supported but not active. And if it's set to 1, that means it's supported and active. So you have to specifically configure a node to be a relay. It doesn't just join the network and automatically it does that. Once it joins the network, you have to send it a packet as a configuration manager to say turn on the relay feature. So it's a very deliberate choice as to making a node a relay. And a part of the managed flood functionality in Bluetooth Mesh is picking judiciously which nodes in your network should be relays. So if you have let's say 100 node network and you make all 100 nodes relays, the performance is going to be relatively poor because you're going to have a lot of devices that are going to try to repeat and relay the same message, where practically you don't need all 100 nodes to be relays. You need some much smaller subset of them to be relays, and you'll still get perfectly sufficient coverage in order for all nodes to get packets reliably. And overall, you're reducing the amount of traffic in the network. So a part of optimizing the deployment of Bluetooth Mesh is being able to pick which devices should be relays to get the minimum number of relays possible to have good network coverage and high reliability.
Okay, yeah, so understanding all those features of the, as you mentioned, a managed flooding style will help optimize the network, not just relay anything here. So,
yeah, it's sort of opposite of the way something like a Zigbee would work, where in Zigbee there's no penalty to having every powered node in your network be a router, because the way it would work is your coordinator would send many to one route requests and build the routing tree, and you would have many different paths and routes you could use to get messages from one device to another. And because routing is done deliberately in Zigbee, so you actually send the path in the packet that you want to, that you're transmitting, how to get from A to B through all of the intermediate devices, there's no penalty to making everything a router. In Bluetooth Mesh, it's not quite like that, so it's sort of an opposite design philosophy from the two. So if you're coming from the Zigbee world and looking at Bluetooth Mesh, a really easy mistake to make would be to think, well, I'll just make everything a relay and the performance will be great. That's quite the opposite, in fact.
Okay, that makes sense. I got you on that. So last question I have is the mobile device, whether it's a tablet or a phone. And you always hear about, Bluetooth Mesh and Bluetooth in general is really popular because everybody has a user's interface. However, what are the limitations or requirements of those mobile devices to really participate with a Bluetooth Mesh network? If you walk into a building or you walk into a home and you know there's a Bluetooth Mesh network, can all devices join? Is there software requirements, hardware requirements? What's going to be the future of mobile devices interacting with Bluetooth Mesh?
There are definitely software requirements. So Bluetooth Mesh isn't like the Bluetooth that's already on your phone. Bluetooth Mesh really is its own self-contained networking protocol. So just because you have a Bluetooth device, that doesn't mean that it understands how to talk Bluetooth Mesh. A good example of that is that I might have a Bluetooth mouse, but it doesn't know how to talk to my Bluetooth headphones. So the mobile device has to have a Bluetooth Mesh stack on board. That's the first consideration. The second thing to consider is that Bluetooth Mesh has two different bearer layers that the network can run on top of. It can run on top of advertising packets, or it can run on top of a GATT, or a Bluetooth connection-based transport, or bearer layer. Most end devices will use the advertising layer. The difficulty is that in order to be a good advertising bearer node, you need to be able to scan with as close to 100% duty cycle as possible. And the reason why that is should make sense, because the advertising packets come in asynchronously, so I have to be listening all the time in order to make sure I get every packet. Smartphone vendors don't let you do that. So you can't send a command to the Bluetooth radio in a phone to say, scan 100% of the time starting now. And the reason why is that it would be very detrimental to the battery life of your device to do background scanning forever. It's sort of a trade-off that the phone manufacturers make between enabling all of the Bluetooth use cases and battery life. So the smartphone can only talk Bluetooth Mesh over the GATT layer at this time. And that's where the proxy devices come in. So a proxy is essentially a bridge between the GATT connection on one side and the advertising-based mesh network on the other side. So in order for a phone or a tablet to join a Bluetooth mesh network, it has to find a proxy and then connect to that proxy. And then the proxy will be the bridge for GATT packets coming from the phone out into the advertising-based network. And then the other way. So anything that wants to send a message back to the phone would send an advertising packet to the proxy through the network, and then the proxy translates that into a GATT packet. Now, there are some product-level design considerations that come along with this. You have to build proxies into your network, which means you have to enable the proxy feature and make sure the proxy feature is configured on the device. But you also have to be advertising that, hey, I'm a proxy, if you're a proxy device. Otherwise, the phone has no idea that the proxy is there. It's scanning, trying to find one, it doesn't see anything, because you physically have a proxy within range of the phone, but the proxy node isn't advertising, hey, I'm a proxy. So that's definitely a consideration to make when you're designing a Bluetooth mesh product, is if I want the phone to be able to join the network somehow, I need to build proxy devices into the network. And the final comment that I'll mention is that the phone is just like any other node in the Bluetooth mesh network. So if I take a phone and walk up to some random network that's advertising as a proxy, I might be able to see that proxy, but I can't connect to it because I am not provisioned into that network. I don't have the credentials to communicate with that proxy. So you still have to provision the phone into the network to give it the security credentials for that network. And then you have to scan for proxies that are on a network that you're a part of.
So definitely for mobile devices, you're telling me that either a company like a Katera or another third party can develop software, or Apple might eventually develop something, but there's going to have to be an application that's running a Bluetooth mesh stack. It's going to be required to join the networks as you would expect through secure connection. And so those are the software requirements that are going to be put on the end suppliers of mobile devices and also control systems like your company.
Yeah, for sure. Another option that a product designer would sometimes consider would be to say, maybe the phone doesn't talk to the network directly. Maybe I have some embedded Linux box that manages the network, and then I do a internet connection. Like maybe it's a cloud-to-cloud connection from this border router, for lack of a better term, to the phone. And you can certainly do that as well. Bluesy is an open source Bluetooth stack that includes Bluetooth mesh support. And I was just reading earlier today, actually, a really interesting white paper about how to set up a Raspberry Pi running the Bluesy mesh networking stack to act as a provisioner and a configuration manager. So you can take a sort of off-the-shelf Linux hardware and turn that into a Bluetooth mesh node as well. So if the limitations of the proxy connection don't sound as appealing, or if you want to be able to build a network where you don't have to have proxies, you could try something like that as well as a product designer, where you have an embedded Linux box that bridges mesh to cloud using something like Bluesy. Okay,
that's good information for people to be made aware of. So, Max, if there's anything else you want to share, otherwise that is the last question I had.
I think that pretty much covers it for me.
All right. Well, I appreciate your time. I know the listeners probably learned quite a bit from your 2 episodes on Bluetooth Mesh, and I'll keep you in the loop. And if there's questions that come in from the listeners, or we get some feedback for other topics to talk about, maybe we can have a conversation in the future.
Yeah, that'd be great. And I know I closed the previous podcast with this little plug, but I do feel like I should mention it again. But if you're planning to build a Bluetooth mesh product, you have to get sort of associate or adopter membership with the Bluetooth SIG. And if there is more information that you'd like to learn about Bluetooth mesh, I would definitely recommend joining the Smart Building subgroup. It's open to all levels of Bluetooth SIG membership, and there's weekly conference calls chaired by Silicon Labs to help feed new requirements into the specification and to discuss the requirements and progress of existing specifications under development. So if you're serious about designing Bluetooth mesh products, that's definitely what I would recommend. That's what we've chosen to do as an organization, and it's been quite helpful for us.
Terrific. I'll put that link in the podcast description so people can go straight to the site to register for that, or if they have to create an account, as you mentioned. If they're going to develop and they have to be an adopter, they're going to have that. So I'll just point them to the Smart Building subgroup link. That'll be good.
Yeah, that'd be fantastic.
All right. Well, again, thanks, Max. Thanks to all our listeners, and hopefully you guys tune in to our future episodes. Our next episode, we're going to actually be talking about Thread and how Thread is also gaining momentum and some of the open thread initiatives that we're seeing in the marketplace. So thanks, Max. Have a great week, and thanks to our listeners.
Yep, you too. Thanks for having me on.